All right, so in 9.5, inscribed angles. Just take the idea of inscribing an angle in a circle, just like you would inscribe a polygon or anything like that, and a couple of ideas with that. An inscribed angle whose vertex is on the circle is contained by two chords that intersect at the point of the circle. So the vertex is on the circle. The angle and the arc are opposite each other. So the arc is opposite the angle is opposite the arc. The theorem behind that is that if the arc is 80, the measurement of the angle is 40. The theorem states the measure of an inscribed angle is half of the measure of the intercepted arc. Intercepted arc is 80, angle is 40. The corollary. If two inscribed angles intercept the same arc, then the angles are congruent. As you can see, the blue chords create an inscribed angle with the same endpoints on the circle as the red chords. Therefore, the angle that's the inscribed angle for both the red chords and the blue chords is the same. The second corollary says that the inscribed angle is in a semicircle with the two endpoints of the chords on the endpoints of the diameter, then the inscribed angle is 90 degrees. And finally, if a quadrilateral is inscribed, the opposite angles are supplementary. Thinking of it like this, you have opposite angles with a quadrilateral that has to be 180. So these chords have to form angles as inscribed angles that must be supplementary. Hit pause and answer questions 1 through 5 on the front and then 6 through 9 on the back. One of the other theorems that's involved with this is when we have a tangent involved and the angle created by a chord and a tangent is equal to half of the intercepted arc. The arc is just formed by the chord, and the tangent and the chord are the vertex at the point of tangency. So the measure of the angle formed by a chord and the tangent is equal to half the measure of the intercepted arc. If the arc is 140, the angle created by the tangent and the chord is 70. State if each angle is an inscribed angle. If it is, name the angle and the intercepted arc. So number 1, BAC, is it inscribed? Yes, the angle is BAC and the arc is arc BC. Number 2, is the angle inscribed? No. K has to be on the circle. Number 3, yes, with arc WV or VW being the intercepted arc and angle VXW or WVX. Finally, this is a central angle, not an inscribed angle. Now, we have an inscribed angle and its relationship with the central angle is the same as the measurement of half of the arc. Therefore, if arc LK has a measurement of, say, 100 degrees, then angle KML would have a measure of 100 degrees. If I then took an inscribed angle and put the inscribed angle, for instance, right there, the inscribed angle would be half of the central angle as long as it has the same endpoints. Find the measure of the arc or the indicated angle. Hopefully you found that arc BC is 80, therefore arc angle A has a measurement of 40 degrees. And in number 2, WXV has a measurement of 42 degrees. The opposite arc that's inscribed has the double measurement of 84 degrees. Also, angle XWV should have a special measurement. Do you know what it is? It should be 90 degrees. X and V are the diameters. XV is the diameter, and therefore W would be the inscribed angle of a semicircle, making angle XWV 90 degrees. Finish up the rest of the worksheet, numbers 10 through 21, and bring that to class on Monday.